Every year, humanity produces more than 430 million metric tons of plastic. That is an almost ridiculous amount of material. And the really crazy part is that less than 10% of all the plastic ever produced has actually been recycled. The rest ends up in landfills, rivers, oceans, soil, and increasingly, inside living organisms. Scientists have detected tiny plastic particles in places you definitely did not expect them: human blood, lungs, and even arteries. Now imagine being told that one of the most promising alternatives to plastic comes from a plant that can grow more than a meter in a single day. Yes, bamboo. In October 2025, researchers from Northeast Forestry University in Harbin, China, reported a remarkable new material made entirely from bamboo. They called it BM plastic, short for bamboo molecular plastic. Unlike ordinary bioplastics that simply mix plant fibers with petroleum-based polymers, this material is created by reorganizing the molecular structure of bamboo itself. And according to the research, it is not just environmentally friendly, it is surprisingly tough. The material can withstand around 110 megapascals of tensile strength, performs strongly in bending tests, tolerates temperatures above 180 degrees Celsius, and can survive extended exposure to high heat. Most importantly, it reportedly breaks down in ordinary soil in roughly 50 days. That combination is what makes this story so interesting, because replacing plastic is not as simple as saying, let's use plants instead. Plastic became king for a reason. It is cheap, lightweight, waterproof, durable, easy to mold, and incredibly useful in everything from food packaging and electronics to medical equipment and car components. So the real challenge is not creating something biodegradable. It is creating something strong, affordable, manufacturable, recyclable, and biodegradable. For decades, scientists have struggled to get all those boxes checked at the same time. And that is where this bamboo discovery gets seriously interesting. Because the researchers were not trying to make bamboo look like plastic. They were trying to make bamboo become plastic. And the chemistry behind that idea could be the most important part of the entire story. The biggest problem with bamboo is also the reason it is so strong. Inside bamboo are long molecules called cellulose. These molecules give plants their structure, but they are held together by extremely strong hydrogen bonds. That arrangement is excellent if your goal is to make a bamboo stalk stand upright in the wind. It is terrible if you want to melt that bamboo down and turn it into a smooth, moldable material. Regular plastic is easy to process because heat can soften it and allow factories to shape it again and again. Bamboo does not behave that way. Try forcing its structure into a new shape, and instead of politely cooperating, it basically says, absolutely not, and breaks. Scientists have tried solving this problem before. One common approach was to grind plant fibers into tiny pieces and combine them with conventional plastic. The result could be stronger and contain renewable material, but there was an obvious catch. The petroleum-based plastic was still doing the heavy lifting. It wasn't a complete replacement. The researchers in Harbin took a completely different route. Instead of adding plastic to bamboo, they reorganized the bamboo itself. First, they treated bamboo cellulose with a solution containing zinc chloride and formic acid. This carefully disrupts the hydrogen bonds holding the cellulose structure together without destroying the cellulose molecules themselves. Then came the clever part. They introduced ethanol, which helped those loosened cellulose molecules reconnect in a new arrangement. As the molecules reorganized, they created a dense network of new bonds, producing a material with properties much closer to conventional engineering plastics. The result was BM plastic, made from the molecular building blocks already present in bamboo. No petroleum-based plastic glue was needed. BM plastic reached about 110 megapascals in tensile strength, roughly twice the strength reported for PLA, the popular corn-based bioplastic. Its bending performance was also impressive, reaching 6.41 gigapascals and outperforming ABS in the reported tests. Then they turned up the heat. BM plastic maintained its shape above 180 degrees Celsius, while samples exposed to 100 degrees Celsius for 7 days reportedly showed no cracking. And it wasn't finished yet. The material also survived exposure to strong acid without obvious surface damage and could absorb significant energy before breaking. And unlike many materials that become weaker after recycling, recycled BM plastic retained around 90% of its original strength. That combination, strength, heat resistance, recyclability, and biodegradability is exactly why this research attracted so much attention. But there was still one gigantic question. A laboratory can make impressive samples. Can the real world make millions of tons of them? Because replacing hundreds of millions of tons of plastic requires more than clever chemistry. It requires an enormous supply of raw material. And strangely enough, that may be the easiest part of the bamboo equation. And this is where bamboo suddenly becomes much more than just a clever laboratory idea. Because when you're trying to replace hundreds of millions of tons of plastic, you need one thing above everything else: a raw material that can actually keep up with demand. And bamboo has a rather unfair advantage. Some species can grow more than 1 meter in a single day. Yes, while most plants are taking their sweet time, bamboo is basically running a biological construction project 24/7. Even better, when bamboo is harvested, it doesn't need to be replanted from scratch. New growth can come from the existing root system, allowing bamboo forests to regenerate in roughly 3 to 5 years. Compare that with timber trees, which can take decades to reach harvestable size. Bamboo can also produce roughly 5 times more plant material per hectare than conventional timber forests. It can capture significant amounts of carbon while growing and, importantly, can be cultivated on land that isn't necessarily prime farmland. The country has more than 7.5 million hectares of bamboo forests spread across around 20 provinces with more than 500 bamboo species. Its existing bamboo industry generates close to 320 billion yuan annually and supports more than 7.5 million farmers. In other words, the supply chain isn't some imaginary future infrastructure waiting to be built. Bamboo is already being grown, harvested, transported, processed, and turned into products such as flooring, furniture, paper, textiles, and construction materials. Globally, bamboo forests cover around 22 million hectares, with major resources across Asia, Africa, and South America. But here's the part that could make companies really pay attention. BM Plastic reportedly doesn't require an entirely new manufacturing ecosystem. The researchers demonstrated that it can be processed using injection molding, the same basic manufacturing technique used to produce enormous numbers of conventional plastic products. It can also be cut, drilled, pressed, and formed into different shapes. And the manufacturing process has another interesting feature. It operates at room temperature, reducing the need for energy-intensive heating normally associated with melting conventional plastics. The chemicals involved, zinc chloride, formic acid, and ethanol, are also relatively common, while ethanol can potentially be recovered and reused. But there is still one elephant in the factory: money. The researchers estimated BM Plastic at roughly $2,300 per ton, compared with around $1,200 for conventional plastic. That's a serious difference. However, the equation could change as production scales up, and conventional plastic carries environmental and regulatory costs that its sticker price doesn't fully capture. And China appears determined to push bamboo-based alternatives forward. The country launched a Bamboo to Replace Plastic initiative in 2022, and followed it with a 3-year action plan in 2023. Bamboo-related products are already expanding, including tableware exports, bamboo pipes, and even a drone using bamboo components. So the race is no longer just about inventing a replacement. It's about who can manufacture the replacement first, cheaply enough, and at enormous scale. And that race is only beginning. But before we declare bamboo the superhero that is going to defeat plastic, there is one important reality check. BM Plastic is impressive, but it is not yet a perfect replacement for every plastic product on Earth. The material is relatively rigid, which makes it promising for solid components but less suitable for flexible products such as thin plastic bags and wrapping film. And then there is the biggest challenge of all: scale. Making a material in a laboratory is one thing. Producing millions, or eventually hundreds of millions, of tons consistently, affordably, and with reliable quality is a completely different battle. That is where many promising technologies disappear. Traditional plastic became successful because it solved problems extremely well. It was strong, cheap, lightweight, moldable, waterproof, and incredibly durable. The problem is that durability doesn't magically switch off when the product becomes waste. That same plastic bottle designed to survive years of use can remain in the environment for generations. BM Plastic attempts to flip that equation. The goal is simple: strong when you need it, biodegradable when you don't. There is also a bigger lesson here. The global plastics problem is enormous. The world produces hundreds of millions of tons every year, while international efforts to create stronger limits on plastic production have struggled to reach agreement. So, waiting for one perfect global rule may not be enough. Sometimes the faster solution is to create a material that companies actually want to use. And that is what makes the bamboo discovery so fascinating. It isn't simply about replacing plastic with something green. It's about asking whether nature already built the raw materials we need, and whether science can finally unlock them. If researchers can solve the remaining problems of cost, flexibility, durability, and mass production, bamboo-based materials could eventually move far beyond experimental products and into packaging, automotive components, consumer goods, construction materials, and countless other applications. The world spent roughly a century building its dependence on petroleum-based plastic. It won't disappear overnight. But for the first time, we may be seeing a serious challenger that doesn't ask us to sacrifice everything plastic does well. So the next time you see a bamboo stalk shooting toward the sky, remember, you may not just be looking at a plant. You could be looking at one of the most interesting candidates for the next generation of materials. And if nature can hide a potential plastic replacement inside bamboo, the bigger question is obvious. What other solutions are growing around us that science hasn't discovered yet? Because sometimes the future isn't sitting in a secret laboratory. Sometimes it's already growing in the ground. So, could bamboo really help rewrite the future of plastic? Maybe. But the science still has a long road from laboratory success to global production. The exciting part is that we finally have a material trying to combine strength, recycling, and biodegradability in one package. And honestly, who knew the humble bamboo was basically nature's overachiever? If this breakthrough surprised you, hit like, subscribe, and remember, sometimes the biggest technology isn't invented, it's growing quietly in the ground.